Imagine a future where farmers can precisely monitor every inch of their fields from the sky, effortlessly identifying crop health issues before they become a problem. This is not science fiction. It's the remarkable reality made possible by computer vision in agriculture drones. But what exactly is computer vision? In simple terms, it's a field of artificial intelligence that enables machines to interpret and make decisions based on visual data from the world around them. When applied to drones, computer vision transforms these flying devices into powerful tools for modern agriculture. Equipped with advanced cameras and sensors, drones capture high-resolution images and videos of farmland. Through sophisticated algorithms, computer vision analyzes these images, identifying patterns or anomalies that may be invisible to the human eye. This technology can assess crop health by detecting variations in color, size, and texture, which may indicate disease, pest infestations, or water stress. By using computer vision, farmers gain the ability to monitor large areas quickly and accurately, leading to more informed decisions and efficient farm management. Consider a large-scale wheat farm in Kansas. Traditionally, assessing the health of such a vast field would require walking the land, a time-consuming and labor-intensive process. However, with a drone equipped with computer vision, the farmer can survey the entire area in a fraction of the time. The drone flies over the field, capturing detailed images that are processed in real time. The computer vision system analyzes these images, highlighting areas where the wheat plants are not thriving. Perhaps there's a patch of brown where the leaves have withered, suggesting a lack of water, or a section where the plants are unusually small, indicating a nutrient deficiency. In another instance, a vineyard in California employs drones with computer vision to monitor the health of grapevines. The system detects subtle changes in leaf color that may point to early signs of disease. By identifying these issues early, the vineyard manager can take targeted action, such as adjusting irrigation or applying treatments, preventing larger problems from developing. This proactive approach not only saves time and resources, but also enhances the quality and yield of the grape harvest. The use of computer vision in agriculture drones extends beyond crop monitoring. In some cases, it aids in the optimization of planting patterns by analyzing soil conditions and identifying the most fertile areas for planting. It can also assist in managing livestock, tracking the movement and health of animals with remarkable precision. This integration of technology into traditional farming practices is revolutionizing the agricultural industry, driving efficiency, sustainability, and productivity to new heights. While the benefits are clear, the widespread adoption of computer vision in agriculture is not without challenges. The technology requires significant investment, which may be prohibitive for smaller farms. There are also concerns regarding data privacy and the potential misuse of the information collected by drones. Nevertheless, as technology advances and becomes more accessible, these hurdles are likely to diminish. Looking to the future, computer vision represents a pivotal shift towards more sustainable agricultural practices. As climate change and population growth put increasing pressure on global food production, the ability to maximize yield while minimizing environmental impact becomes crucial. By embracing technology like computer vision, the agricultural sector is poised to meet these challenges head-on, ensuring food security for generations to come. In this way, the skies are not just a frontier, but a partner in cultivating the future of farming.